everybody, welcome back and happy Friday. You have survived yet another week, and for so many of us it was that first week at home with homeschooling. This was hard. This was a challenging week, but I have to give super big props to all teachers who planned remote lessons for the first time ever. You're awesome superstars, really trying this for the first time, and I will admit there's a vulnerability in terms of doing something that you are so unfamiliar with and still trying it. And parents at home, same to you. Honestly, huge props to all parents who are also in this with their kids during this time and working with their kids while at the same time working on their own, or for some, I understand, have even lost their jobs at this time. So this is even challenging on parents and kids in the same way. And yet still, parents are reaching out and trying their best to support kids. Which is absolutely amazing, and to be able to say I need some support, I'm really struggling with this, is a huge thing, and that's what I'm here to do. I'm here to help you help your kids, or put your kids down, have them sit and send me those questions, and I can be with them live. So if you have other questions, comments, feel free to just pop them in. It's a little hard for me to see because I'm doing it from up here, but Michael's in the back. He might be able to see some of the questions and just let me know what's going on, and if you have additional thoughts or reactions, or if there's something to go over, maybe I'm going too fast, maybe there's something that doesn't quite match what your teachers are giving, please just drop those questions in and I'll try and be as responsive and flexible as I can. So our first set of questions comes from a mom of two, Julie in Missouri. And her first question was, her kid is really struggling with adding and multiplying fractions. I would probably guess that the adding and subtracting is a little bit harder than the multiplying. Multiplying tends to be a lot easier. And she didn't give me some questions to start off with, so I went to a site called math-drills.com. Really great. They give you free workbooks, worksheets, answer keys. Lots of teachers use them for different types of problems. So I'm going to just start off with an example. 5/12 plus 1/4. And I'm going to try and go through some of the success points for you when adding and subtracting with fractions. First thing is, you really want to make sure that your pieces are the same size. That's the part of this that makes sense when we're thinking about 12ths and 4ths. Kind of think of a cookie. If I had a cookie and I had to break it up into 12 pieces and give you one piece, or would you want the cookie where I break it up into 4 pieces and I give you a piece? Cookies are the same size. Do you want the one that's broken into more pieces or bigger pieces? Probably want the one with 4, even though it looks like a smaller number, those pieces are going to be bigger because I broke it up into less. So that's the thing about when we're adding, we're not just putting these numbers together. Like a lot of kids in the beginning just think, oh, it's just 16. Can't do that because the pieces aren't necessarily the same. So that's going to be our first success point. We have to make our pieces the same size. So I'm going to think about a few different strategies for helping out with this, and that means we need a common denominator. Okay, so I showed a quick algorithm yesterday that kind of hides this, but I want to go through it a little bit more traditionally, so for other kids who may have a different method. And I'm also going to stack my numbers because it's a little bit easier, it gives me more space to work. So I'm going to put my 1/4 on the bottom. And when working with fractions, definitely give yourself room because there are a lot of calculations, lots of things that you actually do with these numbers. And again, I'm going to think I want these two to be the same. So I'm going to use a method. I'm going to actually try 2 different methods with you. First one, I'm going to call this a ratio table. And the only number I really need are my denominators, 12 and 4. And all you're going to do is skip count until you find something that is the same, a common multiple. And I like to start with a smaller number first. Why? Because if you can get to the smaller numbers, you can find that the bigger numbers, they're going to match somewhere. So I'm going to just skip count by 4s. That's all I'm going to do. So 4, 8, 12, 16, 20. I'm just going to start with there. I'm going to do the same thing with my 12s. 12, 24, 36, 48, and 60. And now all you have to do now is look. I like putting little eyes there because you gotta look at your eyes. You have to look to see, do I have anything that matches on these two? And if you're looking really carefully, I'll give you 3 seconds to look. What do you see? What do you notice? That some of you have seen that there's a 12 in both of these. So that is a common denominator, meaning I can make these the same size. I can make them into 12s. So that's what I'm going to do. I don't have to do anything to this one. This one's good. Leave it alone. But I want to turn this one into a 12. So now you have to just think how many 12s, how many 4s made 12. And if you don't know, you can just look at your skip counting. Oh, I did it 1, 2, 3 times. And then you just do the same thing to your denominator and numerator to make it equivalent. So if I count by ones 3 times, 1, 2, 3. So I'm going to times it by 3 and I get 3. Now I have an equivalent fraction, 3 12ths. And now that they're the same size, I can add them together. 5 plus 3 is 8. And you just leave 12 alone. So that's my second point. Once they're the same size, I don't have to do anything to my denominators. I don't have to change them. But for my final answer, I want to do 2 checks. Just two checks. We're going to check, is it improper, meaning my top is really, really bigger than my bottom? Nope, we're good there. It's not improper. It's less than 1. And then I'm going to do a second check. Do I have to simplify? And in this case, yes, we do. We have to figure out, is there a number that I can divide 8 and 12 by? And I actually can. I can divide both of these by 2. I can do that in a future lesson if you're really stuck on how to simplify. And I would get 4, 6. And I like to ask myself again, like I like dividing by 2 just because halves work really well for even numbers. So a lot of times kids will do it again because maybe they don't get that they could have just divided by 4. And so we'll just divide by 2 again. And then you'll get 2 thirds. Some kids would have just said, Miss, I can just divide both of these by 4 and get there in one step. You absolutely can. But some kids need a little bit extra support there. Okay, so that's with the ratio table. I hope that one makes sense. We're actually going to try, again, I got these from Math Drills, so I got some extra ones there. And I'm going to try a second one, not with a ratio table, which is where I would start. If you're struggling in the beginning, I'd start with this. This is the easiest one, the lowest lift for a lot of kids. But I'm going to try, let's say, using the algorithm we talked about yesterday. 1/3 plus 2/5. And this algorithm is just a way of really getting common denominators without trying to find the least common one. And it involves just 3 sets of multiplication. With my kids, I sometimes go like this, like Wakanda with forever. So we kind of multiply in 3 ways. We multiply these numbers, and these numbers. So my common denominator, 3 times 5 is 15. And I can multiply 3 times 2 is 6. And 5 times 1 is 5. So now I have 5 15ths plus 6 15ths. And I can just get 11 15ths. Okay. Now the trick about this is, honestly, it's not a trick, it's not magic, it still works. I'm still finding a common denominator. It may not be your lowest denominator, to be fair. There may be one that the numbers get really big, so just be wary of that. And why does this work? Because if I'm doing, think about our question before, if I'm multiplying this times 5 to get 15, that's why I'm getting 5 over 15, because I'm multiplying it by this number here. And I'm going to do the same thing with 2/5. Notice my 2 is being multiplied by 3, so times 3 times 3. We're already doing times 3 here, and now times 3 up here to get 6 15ths. So it's not magic, it's just that the mathematics is kind of compressed and hidden. And that's what makes this really hard to see. Where is the math? I don't see it in here. So this algorithm can also work for you. If you would like to try that one, you can use this as well. And then you get to, so I call this kind of like a butterfly method. I make an X, and then I go straight, and I do my denominators. Again, I like it because it's fast and efficient, but I would only use this with kids who are really fluent and understand fractions well, because it just seems like a trick, like, oh, you just do this. But why does it matter mathematically? Like, why does it really work? And if you're not able to really understand that, then you're kind of missing out on the mathematics there. So I just want to put that out for you. Okay, just going into the page for a second so I can see what is going on in the world. It seems like there's some questions and things going on here. Okay, so let's keep it moving for a minute. And so that one, we just have A plus B, C plus D. We're multiplying B and D together, and then we're multiplying A and D, and we're multiplying C and B. I'm just putting it a little bit bigger so you can just see I'm multiplying this way, and this way. And some kids can just figure it out kind of just by looking at it. So in that last example, what if I have 3 8s and 4 6? I'm stacking them again. Actually, I'm going to do subtraction instead. Let's subtract these two numbers. I think that works. Okay, and some kids can just figure out, because they're very fluent in their multiplication, they can probably say a common factor of these two is just 24, because they know it. They just know that's the least common one. So I would just use what's called a property of 1, meaning think of what is that number that you're going to multiply by to get that denominator. So this is where your thinking just comes in. And for some kids who are very fluent, again, in multiplication, they would just go, oh, it's 6 times 4. So then you're going to do the same thing over here. This is a property of 1. Property of 1, because I'm multiplying by 1. You're getting 16 over 24. 8 times 3. So again, I'm multiplying. This is still 1. It's just in a fractional form, 3 over 3. And I'm getting 9 over 24. Oh, I didn't want to invert that because I'm going to get a negative number now. No worries, that happens sometimes. So just thinking my denominator stays the same. 9 minus 16 is going to give me 7. So this is just a negative 7. So it's more of a 7th grade level problem. Okay, but those are 3 ways I would use. A ratio table, you can use this butterfly method if you're more efficient, or you can just use property of 1 when you get really fluent with your numbers. So Julie, thank you in Missouri for sharing that one. And she's actually had another question. Her daughter is struggling with multiplication as well. Most kids actually like multiplying. The multiplication and division tend to be easier because we don't have to worry about those denominators. We tend to work across. And if you're looking for some ideas about why it works, I'm going to show you how. But if you want to know why, I'm going to say go to my YouTube page, because I have some videos there about why when we multiply fractions things happen. And even I made a really great video about why we multiply by the reciprocal of the second fraction. To be honest, there are math teachers who don't even know that trick, but no worries. So you can just check it there. But I want to just go through this for her as well. So I'm going to use an improper fraction to help us up top. And what's great about multiplying is you can just multiply straight across. Numerator times numerator, denominator times denominator. And so the trickiness is at the end, this is just very easy, 1, 5, 8, is to just do that check again. Is it improper? Nope, this is great. This number is smaller and this is less than 1. And can I simplify it? 5 is prime, I can only divide it by 1 in itself, so this way. So multiplying is super easy. I'll do another one that may be a little trickier. Let's say I have 1/4 times 8/10. Actually 8/9. We'll do it that way. So there are 2 things that kids can see here, or some teachers will teach you. One, I could just multiply straight across again. So I'm just going straight. 8 over 36. And it's not improper, so good check there. But we do have to simplify it. Notice they're both equal, so I'm going to just use my halving rule to just keep breaking it in half. And I kind of just think in my head, divide by 2. Divide by 2. Of course, you can go for your biggest common factor. If you wanted to use your greatest common factor, we could just do 4. I'll do that to save time. 2 ninths. So what's hard here is that when the numbers get bigger, you have to start thinking, what are those common factors? How can I divide? And sometimes it gets hard when your numbers get bigger and bigger. So some teachers teach kids to just look at the problem and try and look to see, are there any numbers that have common factors on the top and bottom so we can reduce it. And I did this as a little kid, but it was really hard for me to explain why it worked. And I know that 1 is with everything. But with the 8 and 9 don't have a common factor, but 8 and 4 do. I can divide both of these by 2. So 4 divided by 2 is 2. 8 divided by 2 is 4. Honestly, there are some kids who take this really well because they know their math facts. Some just have to wait to the end of the problem to figure it out. But now that if you simplify it earlier, now when you have to keep working, 1 times 4 is 4. 2 times 9 is 18. This is an easier one to simplify. I can just half it again. And I still get 2 ninths. Some kids could even go and say, wait, you know what, miss? You could have simplified this even more and even faster. And you know what? They're right. Some kids probably went, I could divide both of these numbers by 4. Okay. 4 divided by 4 is 1. 8 divided by 4 is 2. And it gets even faster. Here's 1 times 2 is 2. 1 times 9 is 9. And they do it in one step. To be fair, the simplifying is going to happen somewhere in the problem. You could either do it here in this expression, or you can do it at the end when you get to that part of the problem. But that's probably the hardest part. Multiplying itself is pretty easy. Pretty easy to do. Okay, but then what about dividing? Dividing can seem a little tricky. So some kids have to remember this rule. Why can't we just divide straight across? 1/3 divided by 13 ninths. Okay, so to be honest, you can divide in this way straight across, but my numbers don't really work well. So 3 divided by 9, I'm going to get already a decimal, so it doesn't look as friendly. So what we can do, and again, you can go to my YouTube page if you want to see why this works, but we have a way of remembering this. Keep, change, flip. And this is just the steps for dividing a fraction. It means we're going to keep the first number, we're going to change this to multiplication, and we're going to flip this around. And now it's a multiplication problem that we can solve. 9 over 39. It's not improper. Can we divide it? Can we simplify it? Yes, I can divide both of these by 3. I probably could have seen that because these two are divisible by 3. So, if I can see what I can divide here, I can figure it out here. So let's divide that by 3. Kind of just saw that for the first time in life. That if I can look for common factors not here, I can kind of look here. Okay, 9 divided by 3 is 3. 39 divided by 3 is 13, and we have 3 over 13. Okay, nice and easy. All we have to remember is keep, change, flip. Or my kids keep on going, KFC, like the chicken place. I'm like, no, it's not KFC, it's KCF, keep, change, flip. But for some reason they remember the chicken, or Kennedy Fried Chicken, and then that helps them just remember the steps. Whatever works for you. Okay. So I hope that part was really helpful for you. And we talked a lot about simplifying with fractions. And now we're going to get to some 8th grade stuff. We're going to get to some equations, and we're going to do some graphing. So for this, I really love a website called Desmos. I'm going to put it here for you. So if you don't have a graphing calculator, Desmos.com. It is a free graphing calculator that you can use. You can plot points, you can plot equations, you can plot lines, and it will graph it for you, and you can actually play and manipulate it. I love this site, and I love sharing it with kids because it helps us see what happens with different patterns. And hopefully I'll put up a video later just showing some of the patterns that happen in this work. So she gave me 2 pictures of her kids' work. And we're going to go with the first step, where they had some equations that they have to graph. So for this, again, I like going big and visual, so I'm just using some regular wrapping paper. And you flip it around. It actually has some grids on it, the little squares. So this is always helpful. You can just look inside your closet, and you'll probably find that some wrapping paper may have this. So we're going to use this for today to help out. I'm trying to see 2 things at the same time. It's a little hard. It's definitely a little bit hard to be able to read comments at the same time. So I'm sorry if I'm not answering all questions right now. But it's because of the way my tablet is placed, it makes it a little hard to be able to see. But don't worry about it. We'll keep on moving. I'm going to read through some of the questions in a second when I'm done with this one. Okay, so I'm just going to use this one just for an X and Y. And the first question that came up is, how do I graph y equals 2x minus 1? Okay, so the first thing I want to tell you is that this is a form that we like to use in math called y equals mx plus b form. And the m has to do with the slope, how steep the line is going. Is it going up? Is it going down? Is it going super fast? So it's steep? Is it going slowly? What's happening with that line? And so, for example, is it going up? Is it going down? Is it going down really fast? Is it going down steadily? That's what my slope is going to tell me. And my b is going to be my y-intercept, meaning it's telling me what happens on this line. Like, where does it touch here? So we're going to look at that one over here. So I'm going to use black for a second. Y equals 2x minus 1. First thing I know is that my b, here's my b, it's the one about a coefficient, is at -1. So this is telling me my first point is 0, -1. So I'm just going to go straight, and I can just plot that right there, 0, -1. And the second thing this is telling me here is, this is my slope. So it's telling me my slope is 2 over 1. That I can go up 2 and over 1. My lines like to go this way. We read it, like just like we read from left to right, my line is going to go from left to right. So it's telling me I'm going to go up 2, over 1. Up 2, over 1. Up 2, over 1. So if you put down just a few points, you can actually get a line. So this is just one way that we can just quickly graph a line. I like to start with I want to get it straight through the points. I like to start with my y-intercept first, and then it tells me how to move. And you can even move backwards if you wanted to. If you want to moonwalk, you can go down to boop, boop, and then over here. I didn't make my line straight enough. Down to boop, boop, and over here. So there you go. So that's my first one, 2x minus 1. And then, you know, we had another tricky one. And the question was, well, what about this? What if I have, I don't want to block it too much. Let me erase Desmos. .com. Okay. What if you had -1/2 x plus y equals, I think it was 3? Yeah, 3. All right, again, we want it in y equals mx plus b form. So I want my y by itself. I gotta move this because I want my x to be on the other side. So I want to turn this into a 0 pair. I want to make it its opposite. So I'm going to do minus 2x here. So that becomes 0. And I'm going to do the same thing over here. Minus, it's not 2x, minus 1/2 x. Okay? And I like to have the forming in y equals mx plus b form. So you can just put the 3 right behind it, plus 3. Okay, so there's your form. So you have it. I'm going to move this over. Y equals -1/2 x plus 3. And again, we're going to start with our intercept. So this is our first point, 0, 3. So 0, 1, 2, 3. So we're going to start there. That's my B. There's B right here. And now I'm going to use this, -1/2. So that means it's telling me how I'm going to walk, like if these are stairs. It's telling me I'm going to go down 1/2. Okay, so from here I'm going to go down 1, and I'm going to move over 2. Down 1, over 2. Down 1, over 2. And then I can connect those points. Okay, and if I want to go backwards, you can do the same thing. So just pretend you're walking backwards. I'm going to go up 1, over 2, up 1, over 2. Okay, so that's just another way, and that's how I graph it. I start with my B, with my intercept, and then my slope just tells me how to move from there. And that's just an easy way of just graphing from my center out. So from this way, it's just following the rules, and then when you go this way, you're just thinking backwards. So you're just going in the opposite. Instead of going down, I'm going up because my line was going up. And over here, instead of going up, I was going down because I'm moving backwards. So I hope this part is pretty helpful. Okay, so take a screenshot if you need it, because it's going away in 3, in 2, in 1, and happy birthday! This one. Okay, then we had another math equation problem, and this one was fun because it felt like a puzzle. So it was asking, how do I make an equation if I just have 2 points? So for example, if I only have, let me write this correctly, -1, 6, and 7, -10. How do I make an equation from that? I just have points. So again, you could go on Desmos and you could actually plot the points and see where to line and try to figure out how far away are they from each other, and try to figure out what that slope is, because I can just do it from there to there. So we're going to try that first. We want this, y equals mx plus b. So let's figure out what the m is. What is our slope? And that means we're going to figure out the change in our y's and my change in my x's. Okay? So I'm going to put this over here on the top, xy, xy. And we know that this one, it goes from 6 all the way to -10. Wow. So I started up here and it went all the way down. And it went all the way down, like if this was a line, it came up from somewhere up here and is all the way down here now. So it's really far. So how much of a difference is that? You could also just do some subtraction, but the subtraction looks a little ugly. So I'm thinking, wow, from 6 to the 0 was 6, and then it went down another 10. So it went down 16. So -16, because we went down 16. And my y's went from a -1 all the way to a 7. So somewhere around here from 1, and it jumped all the way to 7. So again, it passes this axis, so it had to go all the way to here. That was 1, and it went 7 more. So it went 8. So this is my slope I'm getting. My line moved down 16 to get from this point to this point. I went down 16, and then I went over 8. And we can simplify this to find the actual slope. So I can use this, or I can simplify it. And I can simplify this to -2, or -2/1. You can use either one. So I'm going to put that in for my m. Y equals -2x plus b. Now we got to figure out what the b is. So I tried to think of the best way to share this. I hope this part makes sense. Change of y, change of x. And again, use Desmos if you want to just see, if you had trouble with number lines, draw it out on a graph so you can see how far away they are. Because that's a hot spot. That's a hot spot where a lot of kids make mistakes. When it crosses an axis, people forget. They make little mistakes there. All right. So what I'm going to do is I'm going to try and think, what do we know so far? X and y. We know that our slope, our m, is negative 2 over 1, meaning that my y's are going to go down 2 and then over 1. So these are just going to go down 2, and my x's are just going to keep going plus 1. So let's start with this point over here. We're going to start with the one that was all the way on over here, negative 1, 6. I'm doing that because it's in the negative, so I know it's farthest to the left. And I'm just going to keep on going with this pattern of what if I just keep on adding ones here. So negative 1, 0, 1, 2, 3. And we're going to need some space for this, to be honest. So 0, 1, 2, 3, 4, 5, 6, 7. I'm going to make it all the way to this point. And I'm going to go down 2's over here. So I start at 6. I'm going to go to 4. Then it goes 2 because I'm going down 2's. 0, negative 2, negative 4, negative 6, negative 8, negative 10. Look at all those points. I figured out every single point between these two just using the slope. And it was just because I used the slope to figure out what the pattern is. All right. And now all I remember I wanted was my b, which is some number when x is 0. What is y? That's what I want to know. That's my b right there. So look, when x is 0, y is 4. So now I know what my b is. When this is 0, this number is 4. So there's my equation. Negative 2x plus 4. And I have it there. Okay, so there were some more examples in there I think that she had in the homework. But if anything, please reach out if you need that in a slower method. And I can go through another one at a different time. But this is my method for it. I'm just using, first I want to find what is the m. And that's where I'm using change of y, change of x. What happens from 6, change of y's, changes of x. And once I have that number, I'm going to use this to find out where is my y-intercept. That's my b. That's the second number you need to finish this one off. Okay? So take another screenshot if you need it. Because now we're going to get into our last topic for tonight, which comes from Poughkeepsie. And this is Arilyn's problem. She had a few problems in 8th grade having to do with combining like terms and two-step equations. So just give me a moment to just clear off the board. As this one was, there is a little bit of complexity here. We're going to start with the combining like terms. And honestly, when kids are really struggling with combining like terms, again, I like to use Post-its. And my Post-its are really, really big. To be fair, maybe I should just cut them in half. Just so I can make them a little smaller. Yeah. I'm going to do this. Because when we combine like terms, we're moving around numbers. And on the page, it's really hard to do. But when kids can move numbers around and rework things, things come out a little differently. So I'm going to look at two problems from here. And the first one is 2x squared minus 6x plus 12x minus 3. Okay. We are going to simplify this expression. We're going to simplify it, which means we need to combine the things that can come together. So that's what it means to make it simple. Simplify. And the first thing you need to know is that these are each terms. This is a term. This is a term. Notice I'm putting a negative sign with it. This is a term. And this is a term. Okay? And the reason I like to start off using Post-its is because kids can move things that are alike next to each other. So I'm going to do the same thing. Just so you can see what it is I'm doing. And I start this a lot of times with 7th graders. You can even do it with 6th graders. Anything that makes it hands-on for them where they're manipulating and can start thinking is going to be helpful. So I'm going to put these terms in here. 12x squared, negative 6x, 12x, and negative 3. And why I like this is because you can move them around And what I like kids to do is to tell me, what are the things that are the same? Like, what are terms that are the same? And these two terms are the same. They both have x's that are the same size. So I want them together. I want to put them next to each other. And this kind of looks complicated. I want to put this in front of the other one. Okay? And my 3 is kind of by itself. That's a term. And nothing else is a whole number. It's just a 3. And then my 2x squared is by itself. All right. Now I can do some things that are interesting. I can put these two together. So what this is telling me is I have 12 x's. 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is telling me that I need to take away 6 of the x's. So I can subtract 6x. Okay. So if I have 12, I took 6 away, what am I going to have left? I'm going to have 6 left. So that is what we do when we combine terms together. So I'm going to combine them together. And now I know I have 6 left. Positive 6. Okay? And now I can't simplify this anymore, and I can't simplify this anymore. So my expression is done. I could write this as an expression. This is a positive, by the way. But we do like to have it in descending form, like we want to go with the highest term, so the x squared. So that's usually the standard form. So our answer would be 12x squared plus 6x minus 3. So now that is in simplest form. You cannot simplify that expression anymore. If you heard that growling, that was just Naya because she didn't like the problem until it was simplified. That's just, she was like, no, simplify it, simplify it. She was being expressive. That's my little Morky. She might say hi a little later. Okay, let's try just one more to just make sure we really got it. And again, I'm going to just put these 4 numbers right up. So I have 7k, which is positive, minus 22, that's my second term, plus 4k, and minus 9. Okay. And if you're doing this on pen and paper because your teachers probably want you to show your work, that's fine, but you can just recopy from here. Again, we want things, see, she doesn't like it. She wants them to be simplified. Naya, it's going to happen. I promise they're going to be simplified. So the first thing we're going to do is we're going to put the things that are alike together. So I want these 2 things alike. They're next to each other because they have k's. And these 2 terms together, because they're whole numbers, I want them together. And now I can simplify them. So 4k plus 7k, that gives me 11k. And negative 22 minus 9. Think of a money analogy, because a lot of kids have a hard time with this. If I owe you $22 and I owe you $9 more, can I just give you $13? No, you'd be really mad at me if I only gave you $13 because you already owe me 22 and you owe me more money than that. So think of it as money. If I owe you 22 and I owe you another 9, so I can see, oh yeah, this chick owes me $31. Okay, so that helps because a lot of kids have a hard time visualizing. Why is it if I have these 2 negatives, why does it seem like I'm adding them together? But it just means I just owe you more. I have a more negative number. So that mental part works. So I have 11k minus 31, and now it's simplified. And hopefully Naya will be happy about that we have it nice and simple. All right, we have just 2 more examples super fast because I know we're getting to that late time and so many of us on a Friday night want to sit back and relax. It's been a long week. So I'm going to show just the last 2 topics with 1 and 2 step equations. And I'm going to try and use the analogy of makeups and breakups for a little bit. When we have things in common, we're together. When sometimes they separate, when we have opposites. So we're going to kind of think of that analogy. And we're going to do that with 1 step equation. So 10j is equal to 78. So I'm going to start with 1 steps first. These two, this coefficient, this number, this coefficient, and here's my variable. This tells me I have 10 of these. That's all it is. So when I think of these together, I have to think of an operation. They are connected through multiplication. There's an invisible multiplication symbol right between them. And we don't see it, but you can kind of make it visible by making the little dot. I don't like to use X because if this was 10X, a lot of kids might go XX, and that's too confusing. So we start to use that little dot to represent multiplication. All right, I want to separate them. I want to isolate this X. This X needs to be by itself. This, oops, sorry, not this X. This J needs to be by itself. It's just time. It has to be by itself. So we need them to separate. So if they're tied by multiplication, I'm going to separate them using division. And we're going to divide by this coefficient, 10. Okay? So 10 divided by 10 just leaves me 1J. And we don't always write 1J, so we can just leave it as J. So you can see that 1J is by itself now. It has to happen. And whatever I do to one side, I want it to be balanced, so I got to do it to the other. 78 divided by 10 is 7.8. And now I've done that one-step equation. Same thing here. What if these two are tied? 8 plus b equals negative 13. They're connected through addition. So we're going to separate them using the opposite. We're always going to go with the inverse. So if this is addition, I'm going to use some subtraction here. I'm going to get rid of this. I want this to be 0. And so I'm going to think of how do I make an 8 a 0? I'm going to use this opposite, negative 8. Because now there's 0 of them, and I just have this b by itself. It's just 0 pairs by itself. And I'm going to do the same thing to the other side. Now remember, I have 2 negatives here, so think money again. If I owe you $13 and I owe you $8 more, can I just owe you $5? Can I just give you 5? No, you're not going to be happy with that because you're expecting more than 13. So, oh yeah, you got to put them together. So it's negative 21. Okay? So that's what I do it with one-step equations. I just want my variable by itself. I want to isolate him or her. That's the goal. We want them isolated by themselves and then a whole number on the other side. But what happens when we have 2 steps? You know, let's go see that 1-2 step. We have, let's say we do this one. 6 equals a number divided by 4 plus 2. Okay. If it was just this, you know what you would do. Because you see division, so you're going to go with the opposite multiplication. But you got, unfortunately, we made it complicated with an extra. So we're going to deal with that extra first. And I'm going to give you a hint. The extra is usually just a whole number. It's some type of constant number here. And we're going to just get rid of it using a 0 pair. So I'm going to use this opposite. Instead of adding 2, I'm going to subtract 2. So that makes a 0. And now I just have a number being divided by 4 equals 4. And now again, remember, because they're connected, a number is being divided by 4. So I want to break it apart and use the opposite. I'm going to multiply by 4. Why do I do that? Because it just cancels out and it just leaves me with A. And whatever I do to one side, I got to do the other. So I'm going to multiply this by 4 and I get 16. So A equals 16. I am kind of skipping out on one point that all teachers will probably tell you, which is to substitute it in and see if it's true. So if you want to get that extra assurance, you could always just put 16 in there. 16 divided by 4 is 4. 4 plus 2 makes 6. Same thing you can do on any of these. If I put the negative 21 here, 8 plus negative 21, I get 13. And for our last problem of the day, actually I want to do this one. 2 times m plus 5 equals negative 2. So this one looks a little bit more complicated because it has a parentheses. It means I have 2 groups of this. So I'm going to just distribute that so that I can make it more simple. Anything that's complicated, we got to make simple. So I'm going to just multiply 2n plus 2 5s, which is 10, equals negative 2. Remember, if this was just this, we want that. That's easy. So we're going to get rid of this 10. I want to turn this 10 to a 0. So if I have 10, I'm going to do this opposite, minus 10. And do that to both sides. So here I have a 2N. Again, money analogy, I owe you $2 and I owe you another 10. I think you're getting the hang of it. You owe me 12. I gotta give you $12. And now I'm gonna separate these two ends. I'm gonna separate with the opposite, which is divide by 2. And now I have N is equal to -6. Okay? And you could always plug it back in if you wanted to. You can say, all right, let's just double check our work. Because especially if you're taking a high exam, why risk it? Just check. So I'm going to turn this to a 6. 2 times 6 is 12. 12. Oh, there was a -6. Sorry. 2 times 6 is -12. -12 plus 10 gives me -2. So it's still correct. And that's our last question for today. Whoa. We went through a lot today. We went through graphing and simplifying and fractions, which freaks so many people out, but fractions can be really friendly. And I hope you found this really interesting and really helpful. We did quite a lot: adding, subtracting, multiplying, dividing fractions, 1- and 2-step equations, graphing equations, making equations from 2 points. That was a lot, and kudos to you if you were following along. But if you have more questions or comments, feel free to just add into comments. Reach out to each other and say, you know, I'm wondering about this, or what happens in this case. A lot of interesting dialogue can happen, and the more information, if you need more support, the more information I have, the better I can support you. So I hope you had, again, a really happy Friday, TGIF, and you're ready for the weekend, and I will see you more next week. Take care.